Okay, now in this video we'll look at some real-life applications of proportions in similar figures. Okay, so we'll look at this example with the shadow of a tree, shadow of a flagpole. Then you'll do a flagpole question yourself, and then we're going to estimate the height of a tree armed with nothing but a stick, okay, and a measuring tape. You can now estimate the height of a tree with a stick and a measuring tape. Okay, so let's start. At 4 p.m., a 50-foot tree casts a 24-foot shadow. A person 6 feet tall will cast how long of a shadow? Okay, so what we've got to think about is the sun. That's the sun. So the sun, you know, is at 4 p.m. basically. It's just telling you that it's in the same position in the sky. And so when the sun shines down, let's see, so you know the tree will have a shadow of itself on the ground, okay, like that. And the point is that at the same time of day, the sun, the angle that the shadow makes is going to be the same. I mean, the length of the shadow proportionally on the ground will be the same at the same time of day. So what we're told is the tree is 50 feet high, okay, and the shadow is 24 feet long. The person is 6 foot high, so how long of a shadow will be cast? And that's what we got to find. So we do not know the length of the person's shadow, okay? Okay, but basically what we're looking at are two triangles. You've got this triangle here, the tree, the shadow, and how the sun shines down, and the triangle with the person and its shadow, okay? So what we have are similar figures. We have one triangle which is 50, that's the height of the tree, and then the shadow is 24 feet long, and this angle here is the same. Okay, we've got another triangle that is 6 feet high. This distance is unknown, we'll call it x because we don't know it. But again, this angle is the same. Now this is also a right angle triangle. So we do amazingly have similar figures. We have triangles of the same shape. And we know what to do from here. We need to find the value of x. So we can simply do this. Let's say 50 over 24. This long side over the 24 equals, say, 6 over x, right? That's one way of doing it. You could also do this. You could say 24 over 50 equals x over 6, and that would be fine too. But in either case, we then cross multiply, and we should come up with the same thing, which is 50 times x equals 24 times 6. Then just divide both sides by 50 and calculate the value of it. Okay, so the shadow of a flagpole is 10 feet, and that's at 11 a.m. The shadow of a 5.5 foot person is 1.5 feet, 1.5 feet. How tall is the flagpole? So the person is 5.5 feet high, 5.5 feet tall, and their shadow is only 1.5 feet long. So, you know, looks a bit like that. And, you know, the sun is shining, sorry, the sun is over here, it's shining down, and it's giving the same angle. This angle here is the same for all shadows of all vertical objects. And so we're told that the shadow of the flagpole is 10 feet, but we don't know the height of the flagpole, so that's unknown. Okay, so if we look at this now, we have this triangle, we have this triangle here, and then we have this triangle here with the person. So this triangle here, the height is unknown. This distance is unknown. That's the height of the flagpole. This distance is 10. And you know, these angles are the same here. And they both have a right angle. And so this third angle has to be the same also. So these two triangles are similar figures. They are the same shape. This is length of 1.5. This is length of 5.5 here. Okay. And so we can use a proportion to get the height of the flagpole. So we could say x over 10 equals 5.5 over 1.5. X over 10 equals 5.5 over 1.5. So the long side over the short side equals long side over short side. Or you could have done this. You could have went 10 over x, short over long, equals 1.5 over 5.5. So short over long equals short over long. Either way, you should get the right answer in the end, because when you cross multiply, you get 1.5x equals 10 times 5.5. And then just divide both sides by 1.5 and we'll get x by itself. So x equals the height of the flagpole, and it's pretty exact. So it's pretty cool that we can calculate the height of an object using shadows without having to climb up here with a measuring tape. So if you want to calculate the height of something tall, please use shadows. Do not climb it and break your neck. Okay, let me let you try this example. So press pause on the video and try that. So the shadow of a flagpole at 9 a.m. is at 14 feet. The shadow of a 5-foot person is 2.3 feet. How tall is the flagpole? Here's the flagpole. It has a shadow of 14 feet. Here's the person. Person has a shadow of 2.3 feet on the ground. The flagpole's height is unknown, x. The person's height is 5 feet. And the shadow, of course, looks like this. The sun is shining and the shadow comes down, and so we have similar triangles with the same angles, and we can form a proportion. We can go long over short. X over 14 equals long side over short side, 5 over 2.3. Because we have similar triangles, we can cross multiply and get 2.3 times x equals 5 times 14, and then divide both sides by 2.3, and we should have x equals, so that's the approximate height of this flagpole, 30.4 feet. So you have just calculated the height of a flagpole given the length of the shadow of the flagpole and the length of the shadow of a person and the height of the person. So that's a pretty cool application, I would think.